Good to see you, Nick. It's been a while.
Yes.
I was thinking of that.
Just nice to see people in general. You know,
Yeah.
I've been reporting to the office the whole time, but I'm basically here by myself all day. So.
Right.
All right, good afternoon, everyone. Thanks for joining us for the special hauling permit session. Unlike the normal typical first session on Fridays at the safety conference, I don't think people have the excuse for being late this year, so hopefully we have a good turnout. So we got two topics for you today. The first is going to be discussion on the Yankee Dryer super move that happened a while back. And then we're going to have a conversation on the APRAS modernization project. So both sessions or both topics are going to have two speakers. So I'm just going to do the intros for each of the speakers now to save time. So the first topic will be the Yankee Dryer super move. And the presenters will be Nick Nanoski and Jim Roman of District 2. Nick is a transportation construction manager at the PennDOT Engineering District 2 office in Clearfield, and he manages the special hauling and highway occupancy permit office. Nick began working for PennDOT in 1998 and has held several positions in the district's construction division and became the district permit manager in 2012. Nick is a graduate of Penn State University, and his hobbies include golfing, hunting, and fishing. And the second speaker for the Yankee Dryer Superload will be Jim Roman. Jim is a senior civil engineer supervisor transportation for PennDOT District 2. He manages the traffic signal and traffic impact study programs and has 20 years of experience working in the traffic unit. Jim previously served 4 years as district highway safety engineer and currently has over 4 years serving as the assistant district traffic engineer for signals. Jim's also a graduate of Penn State with a Bachelor in Civil Engineering and is a registered professional engineer. In his spare time, Jim and his wife, Lori, like to garden, rock hounding, and tending to their horses and dogs on their hobby farm. So then the second presentation will be APRAS modernization. It'll be a co-presentation between Ben Huffnagel and Bob Pento. Ben is the project manager for PennDOT's APRAS modernization project, which is being executed as part of CAI's application managed services team at PennDOT. Ben has been with CAI for 6 years and has managed project at various state agencies, including Pennsylvania Department of Education, Gaming Control Board, and Fire Academy, as well as the South Carolina Department of Health and Human Resources. Ben graduated from Shippensburg in 2006 with a BS in computer science and enjoys running, golfing, and spending time with his sons. And then finally, our fourth speaker, second for the APRAS modernization, will be Bob Pento. Bob manages the traffic engineering and permit section in the Bureau of Maintenance and Operation, working in the Highway Safety Traffic Operations Division. In his role, Bob oversees statewide policy for traffic engineering studies, pavement marking and signing, highway occupancy permits, oversized overweight hauling permits. He graduated from Penn State in 1991 with a BS in civil engineering and has held several positions with the department, first in District 5, and since 1998, he's been with us down in Central Office. Bob is a registered professional engineer and a member of the Institute of Transportation Engineers. And I'll be moderating today's session. My name is Doug Tomlinson. I'm Chief of the Highway Safety and Traffic Operations Division. I think many of you probably know me over the years. I've been with PennDOT since 1994 and worked in a variety of different positions, all under highway safety and traffic. So with that, I'm going to turn it over to Jim and Nick to get us started with the Yankee Dryer Superload. So take it away, guys.
Thanks, Doug. And again, I'm Nick Nanoski, District Permit Manager for Engineering District 2. I will be leading this session off, followed by Jim Roman from our signal section. So what we're going to be discussing today is a superload move that occurred last December. It was an industrial dryer moving from the Port of Erie to the city of Lock Haven to the first quality plant. In Pennsylvania, well, this was one of 6,200 superload permits issued in 2019 by all the districts combined. And Pennsylvania definition of a superload is the load has a gross weight exceeding 201,000 pounds, or a total length exceeding 160 feet, or a total width exceeding 16 feet. This dryer was part of a $450 million expansion project at First Quality Tissue in Lock Haven. The dryer was shipped from Sweden to the Port of Erie. The first preliminary application, at least that was brought to my attention, was submitted in February of 2018. The dryer moved from December 5th, 2019 to December 16th, 2019. Total route length was over 300 miles. This application took on a life of its own. It required coordinations between Central Permit Office and the permit traffic and bridge units in districts 1, 2, and 10. The preliminary application sparked a lot of different conference calls and meetings to be held. Again, this started in February of 18. The permit was not issued to December of 19. So we fought this for well over a year and a half. The other dryers at the plant were shipped into the Port of Philadelphia and then trucked to Lock Haven. They remember those dryers being delivered here in our office. They were a fight, but not like this one. Sorry about that. The actual dimensions of the dryer were a gross weight of 628,000 pounds, a total length of 217 feet, 4 inches, total width of 20 inches, total height of 19 feet, 11 inches. Kind of get a grasp of the size of this thing when you look at it compared to a full-size pickup parked next to it. And this picture was from the Port of Erie. This definitely wasn't the largest load that was moved in Pennsylvania in 2019. Just the required routing and the unique dimensions, because this thing's basically a big circle, brought on some unique challenges. Again, based on the height, we had to miss all kinds of overhead structures. The weight, we had to miss multiple bridges. The width, when you're on a dual lane highway, we had to close the entire roadway until the load passed. We explored, actually had them explore moving it by rail, and that wasn't possible either because it wouldn't fit through their tunnels. If you Google the trip between the Port of Philadelphia or Port of Erie and Lock Haven, this is what Google recommends you do. In reality, this is the route they ended up taking. It increased the trip length from 230 miles to 304. It required multiple crossovers and wrong way movements on SRs 879, 322, 220, and 120 within District 2, and literally took this route over the river and through the woods. This picture was taken from the roof of our district office as it was on Interstate 80, crossing over the Susquehanna River. All of the different structures that the load crossed required manual computations for maximum load allowance. These were done manually by Peak Engineering. They were hired by the hauler, then reviewed by the district. We also required pre and post bridge inspections. So this move was completed in December. So they were out there in January in boats doing the post inspections. It's a very unique move. The first day it traveled 7 miles. This is day 2. Due to the traction issues, they weren't able to make this grade. They showed some ingenuity, hooked up to it with a grader. It's rumored but not proven that the operator said, "Hold my beer and watch this," before he started tugging it up the hill. And I believe the guy hanging off to the side of the load or off the side of the grader is there as a counterbalance, but I'm not exactly sure what his function in this was. It seems comical at the time, but this literally started the conversation is, should we pull this thing off the road? Can they safely get it the route that they've picked? because basically the horse was out of the barn, we decided that we allowed them to continue. But what they did is they brought in additional push trucks as well as additional bucket trucks to start lifting the wires. Again, this is a typical section of a 2-lane roadway. Again, you can see how it's taking up the entire, both lanes. So there's obviously no oncoming traffic can pass. Traffic control was handled by 4 state troopers, 3 up front to close the roadways off for oncoming traffic, 1 following behind so no one would come, from behind to approach the load. That worked pretty well because no one likes to argue with the guys with the badges and guns. Had 2 separate breakdowns during the trip. This was day 3. They did not get off to a good start. This was up in District 1. The load was fixed and operational by about 7 p.m. So we had a nighttime closure of this of this route in District 1. The detour was implemented and enforced by our district maintenance forces. So we had to call a crew out to handle this one. This is down at the bottom, just outside of Port Matilda. They had to do a wrong way movement. They went eastbound in the westbound lanes of 322. This is the divided section of 322. And then at the bottom of the mountain, they needed to use this crossover, which was to be widened and stabilized. Unfortunately, the stone that they had put for the widening was too saturated because it was a rainy, snowy day, and it ended up getting hung up. They brought in more crane mats, et cetera. This shut down 322 eastbound and westbound for over 3 hours, and this is just west of State College. The second breakdown was on I-80 between Lock Haven and Loganton. This is the climbing lane section of Interstate 80 to the easternmost part of Clinton County, if you're familiar with the area. This was at mile marker 182. All 3 lanes of Interstate 80 eastbound were closed for multiple hours. They were, at this point, 5 miles short of the crossover they needed to get to at the end of the day. This, of course, delayed it because, again, they had to go east of Lock Haven to turn around to come back west to avoid an overhead bridge. During the overnight hours of the night, when they finally did get it to the crossover to park, it snowed. The following morning we had a conference call between PEMA, the department, the hauler, and our county maintenance forces from Clinton. They pre-treated I-80 starting at 4 a.m. We had to call at 5 a.m. The guys out there on the mountain felt that it would be okay to go, but as an added safety feature, we had a plow truck lead it down back off the mountain until it got into the city of Lock Haven. To miss some of the traffic issues within the borough of Ridgeway, we started the load at 4 a.m. that morning to get it through before morning rush. Even with that said, the Ridgeway School District, as well as the Catholic School in Ridgeway, both issued 2-hour delays because they were afraid the buses were not going to make it. But it actually, and Jim's going to elaborate a little more on this too, getting through Ridgeway, but they were outside of the borough limits before 7 a.m., so would not have impacted the schools. Valuable lesson learned, we did the exact same thing the following morning in the borough of Clearfield. Missed the morning rush in the downtown area, then it proceeded up towards Interstate 80, which is past our district office. Now, supposedly some of our folks were late because of load. I think they were going to be late anyway because we were out of there before 7. Also, you notice all the looky-loos here. It was very popular. This is in the small town of Penfield. Despite all the multiple roadways that we had impacted with this trip and, the slowness of how the load had to move, to do the lifting of the wires, thousands of wires, we did not receive a single complaint from the traveling public. The phone calls that I was answering were to tell people where the load was going to be because people were afraid to miss it. There was a gentleman that was part of this. I believe he was one of the escort vehicle drivers. They took off. and he would for the day, and I don't want to say it went viral because it really only went viral in central Pennsylvania, but it's as close as you can be, I guess, for us out here. Our press offices in District 1 and 2, as well as Central Press Office, were also issuing releases every day to notify the public where it was going to be in approximate times. So we got the word out. It seemed to go pretty well. Like I said, we didn't receive any complaints, so that was a good thing. In District 1, the district permit manager, Andy Bullen, stayed with the load the entire time. It was within their district limits. Once it crossed over into Elk County here in District 2, we utilized 4 different construction inspectors who were on winter assignment. They stayed with the load. They were giving us good pictures, giving us updates as far as where it was going to be for the end of the day, so that way we get the press releases out. And they also were there to enforce any of the traffic control restrictions or watch the signal manipulations and reinstallations. And Jim will go very, very much into the signal end of this. Again, those progress reports were very, very good. The load was completed around lunchtime on December 16th. This picture was taken from the gates of First Quality. Like I said, it was around lunchtime. I think by the time it got inside those gates, I was having a cold beer at a local establishment because this thing was I don't want to do another one of these. What we learned was having a central point of contact for all the districts in the central office was paramount. That way the coordination of the meetings and getting review comments out, both in and out, seemed to work. And then just having someone with the load the entire time, especially being using all department employees, that allowed us real-time updates, and we were finding out about the breakdowns as soon as they happened, so that was good. Again, like I said, this thing took on a life of its own. It was something. So I will turn it over now to Jim Roman, and he will go through the signals section as well as the traffic impacts. Thank you very much.
Hello, everybody. As Nick said, I'm Jim Roman. I'm the District 2 Traffic Signal Section Supervisor. And I'd like to discuss today some of the involvement we had in the superload, which actually was quite a bit. When we first learned about this load, my staff and I kind of brainstormed just what's the scope of this going to be? We know we have a lot of impacts on this, and we were just kind of frazzled, like, where do we start with this thing? We talked to some other folks in our building. Our bridge engineer made the comment that in my 30 years of being here, I've never seen anything like this. So it wasn't just permits unit, it wasn't just traffic unit, bridge unit, it was our whole building was definitely up in arms with this. But we kind of sat down, and once we got further into this, Peak Engineer was hired by the hauler to do a lot of their engineering work and their checks. We found out there were 30 traffic signals or flashing beacons on the approach route in District 2, which is the middle part of the route through Elk County, Clearfield County, Center County, Clinton County. 27 mast arm signals, 3 strain pole signals. Going through the course of the analysis, we determined there were 15 mast arm poles that were going to require temporary arm removals. And I'm going to cover this in a little bit. Threaded plate mast arms, there were 6 of them on this particular route that we had the most concern with due to them being banned. And like I said, I'm going to cover those a little more in detail here in a minute. We the hauler wanted to know, what are you guys' drop dead requirements here? So, we definitely had concerns. Number one, in the Commonwealth of Pennsylvania, as a lot of people know, PennDOT doesn't own the traffic signals. So in our district, we had 12 municipalities. We wanted to make sure that the hauler definitely communicated with them and took into account any of their issues or concerns. So phone calls, emails, we wanted to see documentation of that. In fact, one of our municipalities wanted their own contractor out there the day of the move. So it was important to do that communication. Anywhere an arm was removed, we wanted to make sure that the bolt hardware was replaced with new hardware, and that proper bolt testing was also done in accordance with our proper testing procedures in Pub 408. We didn't want to see tip lifting of mast arms that were still bolted. You're going to see some slides and videos as I move on that show it's not tip lifting. The arms are actually, I'll explain that in further detail. It's not tip lifting, but that was important. We didn't want to see them loosen foundation anchor bolts and spin the poles around about the foundation. Again, these poles were in some cases 40 years old. You're dealing with very old infrastructure. We don't own it. We wanted to be very conservative in this load for the safety of the traveling public. Threaded plate mast arms, we didn't want to see them manipulated. Anywhere there was radar or video, non-intrusive detection. Of course, you've got to calibrate those units. You have to draw detection zones. If you move those, there's the chance your zones are now kind of out of whack. So that was a concern. We had the haulers, engineer, Peak Engineering, develop a traffic control plan that got into the nuts and bolts, the real detailed analysis for each intersection that was in question. Threaded plate mast arms. You might ask, what is a threaded plate mast arm? Well, simply, as you see on the photo in the top right, it is simply a connection where the bolt is threaded into the upright part of the pole. There is no receiving nut on the end of it. According to strikeoff letter 470-09-3, these are now banned in Pennsylvania. The reason they're banned is because there's no way to test the bolts. The Skidmore device that you see on the left there, the way those work is you insert the bolt assemblies, as you see on the right, the large bolt assemblies for signals into that, and you need to have a turn of the nut test done with that in order to perform your Pub 19 rotational capacity testing, as well as your pre-installation verification testing in accordance with Pub 408. The traffic control plan, very important. We had several requirements for this. We wanted the entire approach route analyzed for any overhead utilities. They encountered overhead truss structures, mast arms, utilities, a lot of things, bridges, and Bridge did their own analyses. Unfortunately, we don't have someone from Bridge with us today, but to speak for that part of it, but those guys put a lot of hours into this too. Truck turning templates. You know, this truck is very unique. It could do a lot of cool things. You're going to see some videos here, but we wanted them to prove where you say you can get around mast arms. We want to see that on paper. Show us your turning templates. Unlike, you know, that's not different than any other design we would typically review. We ask for those. Nick talked about earlier route restrictions. You know, this was a good strategy. They did wrong way driving. It avoided the overhead obstructions. Vertical clearance analyses, you know, they went out. They measured these things. We have to inspect the poles because our bridge unit doesn't. It's not part of APRAS or our BMS system. That falls on the traffic unit to do these inspections. Couple pictures here, you know, you may have a guy with a pole holding the utilities up, or in most cases, you actually had bucket trucks. Nick had mentioned that earlier. They had the hauler had to go deploy a lot more of these. Those bucket trucks turned into a very useful asset for the hauler in doing the move in 10 days. Sometimes you need one. Well, as you see here, you got a whole convoy of them. A lot of coordination with this. Two-way radios between the driver, the state police, the convoy vehicles, everybody, the contractor. Communication was very important to see this thing through properly. Now here's a picture of the signal pole getting raised. This is not tip lifting. How they did this, of course, there's a bucket truck with the strap. The signal contractor actually, where the arm meets the upright pole, he would remove each of those bolt assemblies one at a time and replace it with a bolt with a smaller diameter. And if you can imagine, that smaller diameter bolt that was threaded to a nut in the back allowed some wiggle room in the pole. And that is how they actually were able to lift it properly. So it actually was still connected, but there wasn't any stress put on the joint of the arm pole connection. Here's an example of turning templates we asked for on the left. That's their proof that the truck could make it through the intersection without impacting mast arms. The photo on the right shows, in fact, that's how it went the day of. That's a photo from one of our CCTV cameras showing the load moving through that same intersection. Wrong way driving, again, a great strategy, avoids signal poles, keeps costs down for the hauler. As far as some of the engineering part of it we got into, you know, this load, and like I said earlier, the truck had some very unique ways that it could maneuver around and about. It could actually lower only 5 inches. That's not a lot, but actually every inch counted with this thing. Its axles had the capability of being retracted. Normally it sat 20 feet wide. As it went through some intersections, it could retract them to 14 feet. So the wheels could pull in. The benefit of that is you could allow the load to get closer to a curb line. So as you can see here, the commodity's cross-section is circular in shape. Of course, the worst case scenario is at the center line of that commodity. As you move further away from the center line, your elevations drop. So that was actually another strategy that was very useful in retracting the axles and lowering the load to get through the intersections. Here's a specific example I'd like to show you. This is the intersection in Penfield that Nick spoke about earlier. And Peak Engineering went through and put together a list of requirements that we were able to give these requirements to our inspectors that were on site. And actually, they would know ahead of time what was going to happen there. So here you had to lift some communication cables, do something with the signal heads, either remove them or flip them, lower the trailer 5 inches, and retract the axles into 14 feet. So here is actually a video showing this the day of. You'll notice the bucket truck lifting the utilities. You'll notice the signal heads flipped. And you might also notice a lot of onlookers here. This was a popular move. Every little town had a lot of people watching this. Unfortunately, the video doesn't show the end. It did make it through this intersection without any major impacts. Right behind me, you can see we're actually presenting in our Regional Traffic Management Center. This is a great asset that was used during the days of the move through our district. Our operators could watch along where we had CCTV cameras deployed to see what was going on. You know, again, we had inspectors on site, but more eyes for documentation to see if there's any problems. You know, the top 2 photos show CCTV images, it signals. The bottom one actually shows our Rhythm InSync adaptive system on Route 879 in Clearfield County that has video detection. Again, the operator as a tool to district. Next, I'd like to cover some lessons learned. You know, we found out winter assignment inspectors were very key. We used 4 of them. They were the boots on the ground, good for documentation, did a really good job keeping us informed on what was going on. We used the traffic control plan to get out the problem areas ahead of time. Where's the tight turning radii? Where are the threaded plate mast storms? Our inspectors knew ahead of time. We had those lists created. Like Nick said earlier, the early morning moves were critical. Getting out there before the commuter traffic was on the roads. That wasn't originally planned for. That was something that came in as the move started, and it turned out to be a great strategy. It lessened the impacts tremendously. You know, one thing we could look at in the future, of course, you always have things you can work on. We really don't have a policy when we remove arms impacted by superload moves like this. You know, there wasn't necessarily consistency across the districts. Every district kind of said, well, this is how we want to see it done. Might be something worth pursuing and looking at in the future. I'd like to show last here a time-lapse video in Ridgeway showing how this all went down. There's actually 2 signal poles being impacted in this intersection. The one you can see there ahead of you, there's one off the screen a little bit. You can see the bucket trucks going through. You see state police, the contractors are out there. Again, a lot of effort, a lot of people put in some man hours on this move. We have trucks with poles that check for height and clearances. Here comes the superload. It's interesting to watch the truck go through the intersection and kind of see how it manipulates its wheels and kind of backs up a little bit to get through. Pusher truck coming through. You know, and of course, after the truck went through, the work still, it's not over yet. We got to get the intersection back to how it was before the load came through. that's all I have. I guess we can take questions.
So Jim, there's two questions here as we switch over to Ben and Bob. First question was any survey performed as part of the clearance analysis, and was it traditional survey or LiDAR?
There was not. It was based more on using those poles and taking field measurements, nothing really high tech. Peak Engineering did feel pretty confident in their measurements. I know we were skeptical here in the district, but it proved out to be, it worked out pretty well using the just the tools, the hand tools that they used. They got pretty close, within a couple inches, and it worked out pretty well.
Okay, the second question, was there consistency between the districts along the route and for the RTMC regions in this case regarding the contents and requirements of the TCP?
Yeah, in most cases, it was centrally led. Nick actually was kind of working with central office directly from District 2. And we had so many meetings where we were all on a phone call and conference calls to discuss what the requirements were. And pretty much everybody was in unison that this is how we're going to go with this. So I can't speak for what happened in the other districts. I know what happened in District 2 for sure, but we tried to be consistent as much as we could.
All right, one final question, and then we're going to move on. How did you coordinate with railroads for the railroad crossings?
Our grade crossing engineer was actually also involved in this. Like I said early in the presentation, it wasn't just traffic or permits or bridge. Our grade crossing was involved. Pretty much, if you put down the man hours from the district of, what people actually worked, I think it'd be astonishing. It was all hands on deck. And anybody who had a relevant, even our utility person, anybody who had something involvement with this was brought in on board into the team. And we did have internal meetings and meetings with all parties, including the hauler and their engineer.
All right, Jim and Nick, thanks. I like that. That was good. I like the video work that you had. One final note that somebody had posted is they've used TSAM's LiDAR to test under clearances on these types of superload moves. So just as an FYI for others. All right, moving on. The next presentation will be Ben and Bob talking about our APRAS modernization project. So guys, take it away.
Bob, you're on mute.
Mute, Bob.
Okay, thank you. All right. Again, and Jim, great last slide. Nobody commented on that, but we didn't know how badly we would need that this year. So again, thanks for the opportunity for us to present. We want to cover, I guess, related to this other presentation was a good intro. This is going to be an overview of the automated system APRAS that we use to process these permits, and our effort from this past year, well, probably longer than that, I should say, to go through a modernization effort that's been pretty substantial. So next slide, Ben. So again, just to give you some background on special hauling permits themselves, these these are required to move these vehicles or loads that are on Pennsylvania highways that exceed the legal dimensions or weights as specified under state or federal law. So the gross vehicle weight is one of the considerations, and again, that can vary by the vehicle and the number of axles, but typically that's an 80,000 pound maximum weight for a legal load. Anything over that typically would require a special hauling permit. Dimensional restrictions also apply, and again, these can vary, but typically legal size would be a maximum of 8.5 feet in width, 13.5 feet maximum in height, and length of a 53 feet, which is your typical tractor trailer. Next slide. Again, Nick mentioned superloads. So from that presentation, you're very familiar with these. But again, this was just to give you a sense of the dimensions that this category of superloads. And again, these are handled as a separate category under the regulations. But again, these follow a separate process. But again, these are submitted again through APRAS. Next slide. So you probably all understand this, but again, if you don't, why do we need to issue special hauling permits? Again, other than beyond the fact that this is of state regulation, the focus is really preserving highway safety and our critical infrastructure. In 2019, we had over 7,000 crashes on Pennsylvania roadways, in which 122 fatalities occurred. And those crashes these were just the crashes that involved heavy trucks. 22 of those fatalities were the occupants of the trucks themselves. So again, this is definitely an important safety issue that really we need to focus on. Again, from an infrastructure standpoint, of the 41,000 miles of state highway that we manage and maintain in the state of Pennsylvania, this type of traffic, of course, takes a significant impact. In fact, a federal study indicated that road damage from one tractor trailer combination is equivalent to approximately 9,600 cars. So the equivalent level of damage from one truck to that type of traffic. So, and again, we've got 25,000 state-owned bridges, and approximately 13% of those are structurally deficient. So these are all factors that have to be considered in the movement of these oversized and overweight loads. And again, just a couple other pictures to give you a sense of things that can happen when route is not considered. This is an ongoing issue. Bridge strikes. Again, even at legal height, these things happen. So it's critically important that all restrictions are considered and analyzed before an oversized or overweight movement occurs. So just to give you a little sense of what is APRAS, this is PennDOT's Automated Permit Routing and Analysis System. So this is an in-house application that was developed and it was launched in 1998. Users access this again online, and they propose a route for their movement. This online system is used to issue over 400,000 oversized and overweight permits per year. And again, some of you may be familiar with APRAS, but we really recognized that there was a big need to modernize this system to really get it up to national standards and meet the industry expectations from our haulers and our customers. So we've undertaken a multi-phase project to modernize APRAS. And again, I'll get another couple slides here, but then I'm going to hand it off to Ben to kind of go into details on kind of how we're approaching that and where that stands. So again, APRAS conducts an automatic review of the selected route. So the haulers actually enter a proposed route, and there's an analysis that occurs that looks at the bridges that are along the proposed road, whether any of the routes are posted, looks at tight intersections. Are there any ongoing work, including construction projects, that could impact the movement during that specific time frame, and other factors that are considered automatically as part of that analysis. And that once that analysis occurs, approximately the system either automatically generates a permit or it denies the permit. 63% of these are auto issued. We call this auto issued when there takes no manual intervention from PennDOT's behalf to issue that permit. The system automatically does the analysis. The remaining that kick to what we call a manual review, those then, because of some specific restriction, it may be a bridge, it may be some location where there's a restriction, it may take someone from PennDOT's bridge unit or a traffic unit in an individual district to look at that proposed route and make the determination, can that load at that dimension or weight pass through there? And that typically occurs, and those are so those remaining permits that can be issued are typically issued within about a 2-hour time frame from the time they're entered. Others may take longer, depending on the complexity. Obviously, superloads are completely different animal. These would be your kind of run-of-the-mill oversized, overweight movements. So in general, our goals from modernization was really to approach this in phases. And our first phase, which was released last year, really focused on the customer, modernizing the customer interface for our system. It was a complete technology upgrade. And we recognized that we wanted to move to map-based routing. Our current, the previous system, I should say, which we call APRAS Legacy, really required the haulers to build their routes and enter them link by link. We wanted to move to a map-based interface because that's really become the industry standard and what customers expect. We also wanted to improve the workflow for PennDOT staff, permit staff that use the system, and improve their workflow. As well as really improving our route generation and analysis. Again, we wanted to move to a system that would propose to you a route as opposed to you having to suggest a route and the system basically tell you yes or no. So those were kind of our goals of modernization. With that, I'm going to hand it off to Ben here, and he's kind of going to go into detail on kind of the improvements to the system as it stands now and where we're going.
Bob, as you transition here, a question of what are the wheelbase restrictions? Is that more of a WB62 or a WB67?
I think it varies, and that's part of the analysis. If it's something that can be auto issued based on the route and the restrictions that are entered into the system, either coming out of RMS or manually entered, it'll auto issue. If it's not, then it'll flag to manual review, and the traffic unit staff or the permit staff will take a look at that and make that call as to whether that section can whether that design vehicle can pass through.
All right, thanks, Bob.
Sure.
As Bob mentioned, we are doing a phased modernization of APRAS. The project my team took over kicked off in June 2018, where we started some of the initial design requirements gathering and just make sure knew everything we needed going into it. The first release that we had planned was actually a modernization of the external web application. So this would be simply what all of the carriers use to, or carriers and permit services use to apply for an application, generate their route, download their permits and the like. All of the back-end processing, the route analysis, the bridge analysis, as well as that manual review process, everything that's used by PennDOT is coming in later releases. So last December, actually almost exactly a year ago today, on December 9th, 2019, we had the external web application go live. We actually went live with a single customer and slowly rolled that out throughout the first couple months of this year. And it was very nice because that allowed us to kind of do more hand holding, do some lessons learned, make sure all of the documentation was up to date to bring those carriers on, to minimize any disruption that may be happening so that carriers were still able to continue to do business. As we go forward in the next couple of years, as I mentioned, we will be modernizing both the PennDOT internal application, what everybody uses for those manual reviews, as well as the back-end processing. All of the bridge analysis, the roadway analysis, everything that goes deep into even the live load analysis of the bridges, just to make sure you have a safe and traversable route. One thing we mentioned was just getting to an improved user interface. Anybody that had used the previous APRAS system knows that if you didn't know it was built in 1998, all you had to do was boot it up and it sure looks like it was. It was something that was very good when it came out, very reliable, was able to, be in service for almost 30 years. So excellent, but definitely want to move towards a cleaner, more modern interface and something that brings the key information right to the carrier's fingertips. What we're seeing here is actually the dashboard screen that the carriers would see when they log in, all the options they have available at their left, and they can see some urgent alerts that may be there, some applications that they have recently submitted, some permits they've had recently issued, as well as a restrictions map. Those of you that are familiar with 501PA, it has similar information as that. One of the pieces of feedback that we had received from legacy APRAS was, while you could see all of these alerts and restrictions, they were in a kind of tabular format, which can be useful for some reports, but when you're doing your route planning, it's really helpful to be able to see that on a map and then kind of route around it. As we get into that restrictions map with a little bit more detail, what they're able to do is zoom in, see the restriction, in this case, kind of highlighting that there's a road closure on the Camp Hill Beltway. And then by clicking on that restriction, find out additional information. This restrictions map would be showing road closures, construction, other temporary restrictions, and some of those can vary. For a road closure, obviously there's no traversal here. However, a key fact they find is this is only northbound. Similarly, for construction, it may be that the road is entirely closed. It may be a new width restriction, height restriction, length restriction. So it gives them the information they can have to do their detailed planning. This goes back into, and a lot of things we're talking about here kind of go back into that auto issue rate that Bob was talking about. These are some very obvious things that when you're planning your route, if you request a route that goes over the Camp Hill bypass northbound between November 13th and December 14th, you're not going to get a permit because that road is closed. In the previous system, the carriers, as well as needing to build their own routes, kind of make it in a text-based format, they had no feedback until it got to PennDOT. So it could be something very obvious, for example, here, where if you asked for a route that went over a closed road, there's no way you're going to get that route. Similar if you have a 16-foot high truck and there's a 12-foot high bridge, there's no way you're going to get that route. By submitting it, you're just burning time, it's going to get denied. So want to put as much of this information as possible at the fingertips of the haulers so that, you know, why do it twice when you can do it once? Similarly, one of the other data screens that we have here shows posted and bonded routes. As you see on the left, this actually shows all of the posted and bonded roads that are in the Commonwealth. Anybody that is familiar with a map of the Marcellus Shale Formation can see there's a little bit of a correlation here, especially with a lot of fracking going on. These are becoming more prominent. So this, again, allows haulers to do their planning. By default, they would not be able to route over those roads, but especially for those that do have bonds, if they enter the bond information showing that they can traverse that road, we will route them over there. So some useful information comes up here is if there is a section of bonded road, as well as saying where it goes from, what state route it's on, the effective date, also says who holds the bond. In case this is the carrier that doesn't hold the bond on that section of the road, it allows them to reach out and contact to see, can they get permission to traverse and go there, so that if that's where they need to go, they can go. When we get into the interface for actually submitting an application, a lot of things that the team took forward was, one, make this as clean and clear as possible, make sure we're doing things that are expected of a modern application, highlighting fields that are required, kind of giving some feedback as the users go. And then also, more importantly, is we have some adaptive data entry. You can see here that there's a return trip toggle that is turned off. Were the user to be submitting a application that had a return trip, when they toggled it on, there's some additional information that the system would ask for. We don't clutter up the screen with that beforehand if they're not going to use it. Similarly, we don't present that so they don't waste their time looking for it or potentially get denied because there's some information there, or more importantly, get denied because they've not given information that is needed. So want to make sure that, again, get to, this is something that can be done once, go forward. When we get to the heart of this, though, it comes down to the map-based routing. Again, as Bob mentioned, this is something that not only is this generally accepted from haulers who see other systems that are being used across the country, but also it's just part of our life. If you're going somewhere using Google Maps, you're not using a paper map or planning this by yourself. This is something that we wanted to bring in. Previously, as mentioned, all of that planning fell on the haulers beforehand. at which point they had a series of drop-down boxes to select which state route they were traversing, in which direction, going to the next state route, hopping off the like, so that all of that planning now can be brought into the system. So what we're showing here is this is the actual interface that the haulers would use, simply by selecting a start point, selecting an end point, asking the system to suggest a route. This system will generate a traversable route and the most efficient route, just going by distance and speed. System at this point, when suggesting a route, takes into account temporary restrictions, road closures, construction, vertical clearances, horizontal clearances, as well as posted and bonded roads. The actual weight calculations, that live load analysis we talked about, still happens on the back end. We're looking as we modernize to see if we can improve the performance on that, but it's something that just the response time from all of that was taking a bit. So that is now on some of the more detailed analysis. Showing what happens with some of the an overhead structure. So this is actually the same route that we just showed. It'll be right in here where we see the railroad crossing coming off of the Harvey Taylor Bridge. On the left is what happens when you ask the system to suggest a route and you have a 13-foot 6-inch high vehicle, and it goes straight through on the bypass and going. If you change the vehicle dimensions to then be 14 feet 6 inches, for one, the system will force you to regenerate the route. So you can't have a route, change your dimensions, and then submit that route. System will ask you to regenerate, at which point we can see you have a fairly different route. In this one, there's actually, I think it is a 13-foot 10-inch bridge, right, railroad bridge right here. So that shows the routing around it. We're looking at potentially, as we go forward, showing more detail as to why some of these things are happening. But unfortunately, while this one is fairly obvious as far as what's being avoided, there's some cases where the route can be very significant for some avoidance, and trying to kind of zero in on where the change occurred can be difficult. That actually, I think, is showed better here. For the restriction that we showed, that road closure that was on the Camp Hill bypass. We actually have the route flipped, so you are going northbound. On the left is when the restriction is not active. If you remember, it expires on, I believe, the 13th or 14th of December. So the permit on the left would be requested starting on December 16th. And the route goes as one might expect if they don't know of any restrictions, right up Trindle, Camp Hill bypass, and over to Harrisburg. If you were trying to travel during that travel time, I believe I had set the start date of the move to December 10th. The system will now generate you a route that goes around that. As you can see, much more complex, not what somebody might expect if they're saying, get me there as efficiently as possible. But here we are actually going around that restriction. Something that, were they to have requested this permit, it would have gotten denied because they're trying to travel through a road closure. Again, allows them not to get hung up by these obvious misses, and to make sure that they get their permits issued as quickly and as automatically as possible. One of the other things that we allow, as we say, and we have this intentionally saying suggest route. This is not, when the system generates a route, it is not necessarily the route that you must take. We are showing a safe route and the most efficient, as the computer says, but not necessarily the route you may want to take. So what we've allowed are the use of waypoints. So this is the same route starting in Harrisburg, going over to Camp Hill that we had before. But in this case, the carrier had decided that, let's say they are much more comfortable going on highways, or they don't want to go across the Harvey Taylor Bridge. So they've actually put this waypoint on 83 southbound. And so when they put that, the system will then generate a route that, rather than just going from the start to the end, it will go from the start through all waypoints that you give and to the end. Here I show one waypoint, but there could be many. And so if a carrier was trying to say, make the exact route that they're trying to go, they could in theory put a waypoint at every turn they want to make, and the system would go there. Usually, and anybody that's kind of messed around with Google Maps trying to get the route that I want will know, usually one or two will steer it where you need to go. But this is important because what the best route isn't going to necessarily be the most efficient route. What the best route for one carrier is not going to be something for others. And so this allows for that flexibility. One of the things that I note is that they are allowed to specify that they're going off network. The APRAS system will only route on the state roadway network. So if they were taking local roads or the turnpike, they can specify the point at their route that they leave the state network and then specify where they're rejoining the state network. I believe that's where we're at. Doug?
Few questions, Ben. So the first one is about the construction zones and how they're getting into APRAS.
Mm-hmm.
So I know we were doing a connection to RCRS.
Mm-hmm.
How was the construction info getting pulled into APRAS today?
So right now, currently we're working on the process to have that, but the construction are actually put in by the APRAS coordinators out at each district. And that is the process that has been followed with APRAS for years. So all of those that are put into APRAS are then displayed on the map. As you mentioned, we do have an interface with RCRS. We're just working out the business process to make sure that those aren't duplicated within the system.
Okay, second question, is the tool integrated or will it be integrated with GPS tools like Google Maps to make it more user-friendly for the folks in the vehicle?
At this point, we don't have that integration planned. This will be making the turn-by-turn directions that are printed on the permit, but so far we don't have any integrations with a turn-by-turn app like Google in the works.
Okay,
Doug,
so follow up on that. How does the driver use this today?
Ben, I was just going to add that under state law, the driver has to have a paper copy of the permit in the vehicle with them at the time of the move, so they can present that to an officer if they're stopped. So the use now is that the hauler should be reviewing that permit as issued with the turn-by-turn directions, prior to the move, and they have it with them in the vehicle. But there's no, there's not a way to have that automated into some type of navigation system at this point.
Okay, one more question. Has the file size maximum been increased when uploading application documents? I believe it was previously 500 kilobytes, which made it hard to upload PDF documents with graphics such as for a traffic control plan. This has been a common complaint from haulers for the previous application.
I don't know offhand. However, I do know that there are some things that we haven't necessarily been able to improve as of yet, just because of some of the systems that we integrate with, and specifically on some of these where, while it may not be the web app that's handling the documents going into the repository, but certainly that's something that we are looking to improve as we go forward in the modernization. As Bob mentioned, this is a complete, or will eventually be a complete technology overhaul. So by the time the modernization has completed, no servers, no processes, no databases, no web applications that existed before will still be in use. All of those will be updated. And so certainly making sure that we can get reasonable file sizes up is something we'll be aiming for.
All right, one final question from an anonymous attendee who I also believe is known as Steve Galt. For the moderator, did you arrange the light in your workspace so the reflection from the light in Seinfeld's apartment on your head would align properly? Actually, my head is just perfectly aligned to all lighting conditions, Steve. So it works under all lighting environments. All right, I think we've come to the end. I like that session. I got a lot of good information out of that. Hopefully everybody felt the same. We had about 50 attendees that stayed with us the whole time. I enjoyed moderating in bare feet for the first time. So I'm going to talk to Steve Williams, see if I can do that when we're up at the safety conference next year. And we have one more session 30 minutes from now. So find a good one and enjoy. Thanks, everyone.
Thanks, everyone.